Welcome. This video is focused on solving inequalities in one variable, meaning just one variable, maybe x, maybe y, but not both of them. All right, we'll jump right into the y. Of course, many of you have guinea pigs or did at some point, and you had to create some recreational areas for them. Maybe not quite like this one when they're at the beach, or this one that has its own inside soccer field. These guys, okay, this is more realistic because most of them don't have pools either. So here's the realistic one. We got a play area we want to create this in, and there's some limitations. When you go to the store, you can't always afford to buy everything you want. Well, we can not afford to buy any more than 16 total feet of fence. So that's one of our areas where we have a limitation. And looking at some of the other things, it's got to fit perfectly in our backyard. The special enclosure must be 3 feet longer than it is wide. So again, here's where we're looking at some of those limitations. The perimeter, 2 lengths plus 2 widths, that's a formula most of you are familiar with. Adding up all the sides, and it has to be less than 16 feet. And then of course the length must be 3 feet longer than it is wide. So you can see the inequality that's already been written here: 2 sets of lengths and 2 sets of widths. Well, the length had to be 3 more than the width, and altogether it had to be less than or equal to 16 because that was a limitation that we had. And oops, so I wanted to show you this. We're going to go into detail on how to do this, but we're basically solving this linear inequality. Here's the critical thing, really, is knowing what these symbols mean. A less than symbol looks a little bit like an L. Okay, just rotate it a little bit to the right. A greater than symbol, well, it does not look like an L. It doesn't really look like a G unless you throw that on it. Then it looks a little bit like a G. But the point is I know in elementary school they talk about eating the alligator eats the big one, or the Pac-Man eats the big one kind of thing. But you really need to commit to some kind of a visual memory on this, that less than symbol looks like this. It'll make your life much easier if you can commit to that and get that into your mind, and this is going to help. So anyway, so let's jump right into a more detailed view of this. Solving a linear inequality in one variable involves finding a range, if you will, a range of possible solutions for a given inequality. So inequalities say, when I went to the store and I could only buy up to 16 feet of fencing or something, that means I could buy 1 foot of fence, 2 foot, 3 foot, 4 foot. So it was a range of possible solutions for a given inequality. Equations have only one solution, while inequalities have many solutions. And we're going to look and see how you can express that. You can express it with inequalities or in a graphical method on a number line. All right, so solve and graph each inequality. We're going to start by isolating x, which basically means getting it by itself in each of the equations. And so let's start over here. This is a relatively simple one. You can almost think of this as just an equal sign, and we're just going to add 3 to both sides. So we're going to start to isolate x, 2x, the minus 3 and the plus 3 canceled out to 0, is less than 12 now on this side. And then I'm going to divide this side by 2 because it was 2 times x, so I have to do the opposite, and that reduces to 1, and I don't have to put the 1 there. And then the 12 divided by 2 is just 6. So that was relatively simple. It's a lot like solving, well, it's just like solving a basic equations, and there's just going to be one critical difference, and that is that instead of an equal sign, it is an inequality, and we're going to have to address that as we go through it. So this is saying that 6 can be any number less than, x can be any number less than 6. So I'm going to go to my number line. I'm going to put 6, 7, 8, and then of course it's 5, 4, 3, and so forth. And I'm going to represent this on here. Well, it says less than 6, so it could be 5, it could be 4, it could be 3. By the way, it could be 4.5, it could be 4.25, it could be 4.1. And you see what's happening here is I begin to say all the numbers that it could be. I'm really shading this thing in. So that's what the graphical view looks like. It says, hey, any one of those numbers and I keep dotting them in, eventually I'm going to get a solid line over there. By the way, can it be 6? Well, no, it said it had to be less than 6. So how do I represent start at 6 but don't include 6? Well, we do that with an open circle. And that's a way of saying, oh, start here for anything less than or greater than, and then move in the direction that I've shaded it. All right. If it were well, we'll see in the next one where it's greater than or equal to. Okay, so here I have the greater than symbol, the greater than or equal to. And you're saying, well, how can it be both? Well, it's not. That's why we're saying or. It can be greater than or it could be equal to. All right, so let's go through and solve this, and we're going to subtract 7. We're trying to isolate x, and I'm left with negative 4x. Don't forget that negative, drop that down. These balance out to 0, so I don't need to put that there. And then it's greater than or equal to. Now I'm going to combine these. A lot of people run into trouble with the positives and negatives. Think of this as negative 9 minus 7. A lot of people do this. Change. And so subtracting a positive is the same thing as adding its inverse. And so this is negative 16. All right, now we're going to do a critical thing here. We're going to divide by negative 4, and when we divide by negative 4, this is when we're going to flip the inequality symbol. Okay, so anytime you multiply or divide by a negative, you're going to flip that inequality symbol, and it now becomes a less than symbol. All right, so that's a pretty critical understanding right there. You can see that's going to give you the difference between wrong answer and right answer. So I'm going over here 4, 3, 2, 1, 5, 6, 7, and I'm saying any number less than or equal to 4. So of course it could be 3, it could be 2, 2.5. I'm going to go through that same exercise I did before. Of course I don't have to dot it in like that. I'm just showing you that it could be any of those numbers, which eventually becomes a shaded line. Could I include 4? In this case, I can, because it said or equal to, so I'm going to include 4. So I put a circle there, and I'm saying to denote that that's where I'm starting, but I'm filling it in. It's called a closed circle, which means to include 4 as part of the solution set. All right, and let's see, is there anything else I want to say there? Well, another way to check, like let's say you messed up this thing and you were at x is greater than or equal to 4. What I could do is I could test a number, and let me do a little erasure here. I'm going to test a number back in my original inequality, and let's say I had made that mistake and I thought this was the answer. So I'm going to say, well, what's a number that's greater than 4? Well, 5 is greater than 4. So I'm going to test this number and just see if this is true. Negative 4 times 5 plus 7 is greater than or equal to 9. That's supposed to be true according to my mistaken answer that I came up with. It's a wrong answer, but I don't know it yet. I continue to simplify this, so I'm going to simplify this side. I'm not solving for anything, I'm just simplifying. Negative 4 times 5 is negative 20, plus 7 is greater than or equal to negative 9. And then negative 20 plus 7 is negative 13, greater than or equal to negative 9. Is negative 13 really greater than or equal to negative 9? Well, no, negative 13 is further on the left side of the number line, so this is not true. And therefore, that is telling me that, whoa, wait a minute, that didn't fit the test, and so it is not true. So I would maybe test 3 back in the inequality, and if I tested 3 into this, I would get negative 12 plus 7, or negative 5 is greater than or equal to negative 9. That is a true statement. We're on the negatives here. It's further on the right of the number line, so that's kind of proving that it was true. All right, we'll look a few more of those, but I just wanted to get you to that point. Okay, solve and graph. At this point, you can pause the video, try these yourself. Otherwise, stick with me and see how this works. We're going to isolate x, so I'm adding 3 to both sides. I get 7x is less than or equal to negative 14. This is where a lot of people run into trouble. If you don't know your negative and positive integer rules for addition and subtraction and multiplication and division, this is where you might run into problems. So please be aware of that. All right, and now I'm going to divide by 7. Ooh, a minute ago I said if I divide or multiply with something, you have to flip the symbol. But wait a minute, that was if you multiply or divide by a negative. You're going to flip the symbol. If you just multiply or divide by a positive number, it's fine. And you might be saying, but wait a minute, you did a negative number over here. No, this 7 would have had to be negative for that to flip the symbol. All right, so the symbol is going to stay the same. It's at -2. I'm just going to put one number over there, and whoops, -3 and -1, 0, and so forth. All right, so at 2 is our place, and I'm not doing an open circle. I'm going to close it in because it said or equal to, and it's saying less than that, so I'm going to the less than side. All right, and boy, it really would be smart to test something. If this is true, -3 should work in this inequality. So 7 times -3 minus 3 should be less than or equal to -17. I get -21 minus 3, less than or equal to -17. These combine to -24. That's where a lot of people have difficulty, and it comes out true. -24 is less than -17, so I've got the right solution set. By the way, if I put 0 in there, it would not work. In other words, 7 times 0 is 0, and I get -3, less than or equal to -17, and that is not true. -3 is not less than -17. -17 is much less than -3, and that's not true, and that's why it's not part of the solution set. That's why it's not shaded in over there. All right. Let's see. Okay, so we got x on this side this time. So I'm going to isolate x. I'm doing plus 14 to both sides, plus 14. I got 25 over here, greater than or equal, I'm sorry, not or equal to, greater than 2x. I'm going to divide by 2. X is, well, see, I'm kind of reading this backwards. X is less than 25 over 2, which turns out to be 12 and a half. Okay, so I'm going to go over here to my number line, and I'm going to put 12 and a half on here and scale it that way. 13, 12, and so forth. Okay, so this is, I could rewrite this the other way. I kind of like to do this, flip the whole thing over, and it just reads a little bit better according to my knowledge of this. This is a less than symbol. This says 12 and a half is greater than x. So that would mean if 12 and a half is greater than x, then x would have to be over here on this side, wouldn't it? Or what I just rewrote it in this form, x is less than 12 and a half. Okay, so what's a good number I could test? Well, I could test 12. I'd like to kind of go all the way over to 0. I like to test 0. 0 is not on here necessarily, but it's down on that side. And test 0. 11 is greater than -14 plus 2 times 0. The reason I like to test 0 is a lot of other people like to is because it's real simple. 0 times 2 just zeros that out, and plus -14. And 11 over here, whoops, I'm sorry, I wrote -11. So is 11 greater than -14? Well, yes, it is. All right, so, and I was expecting it to be, so that confirms that my solution set is over there on the left. All right, did you notice that we left this as an open circle? That's because it's less than, not or equal to. All right, and again, you can pause the video at this point, see if you get it right. I'm going to subtract 10 from both sides. I got -7x is less than, I did a negative to both sides, but that's just subtracting. That's not multiplying or dividing by, so I'm okay. I'm not going to flip the symbol. Now I'm dividing by a negative. Okay, now I do flip the symbol, and 14 divided by -7, it's a negative, -2. It's saying that x has to be greater than -2. All right, so an open circle there because it's not or equal to, and I'm going to the greater than side. I could test some values. 0 should work in my equation, or my inequality. I put a 0 in there, less than 24. These basically cancel that out because 0 times 7 is 0, so it's 10 minus nothing, which is just 10. And then 10 is less than 24. It's a true statement, and I was expecting it to be true because that's where my shading is. The shading, again, represents all the possible solutions. So this is a visual way of saying, hey, give me everything greater than -2. All right, greater than -2. Think about it. You go to the driver's license place, and how old do you have to be to get a driver's license? Well, it depends on what state you're from. The one I'm in, you have to be older than 16. 16 and a day. It's kind of a strange law, but I don't know. I guess they figure you're going to party too much on your 16th birthday, so they don't want you out driving. But here's a way they could hang a shingle that says your age must meet this qualification. They'd have an open circle there to say don't include exactly 16, but 16 and a day. you're okay. So 16 in a day, and 2 days, and 3 days, and so forth. So 16 with anything is that border, and anything greater than that. All right, last one, I believe. Again, pause the video, maybe try this one on your own. Ooh, this looks difficult. All right, it's got a lot of stuff in it. We got x's on both sides. We've got a little distributive property in there, so let's see how it goes. I'm going to start with breaking up these parentheses. So I'm going to do a little distributive property here, and this negative right there, or subtraction symbol, could throw us off a little bit. Let's watch. That goes with the 3. So I got negative 9 minus 3x, and then negative 3 times negative 2 is plus 6. Ooh, watch that. Some people do this little deal. They change that to plus negative so that they recognize that the negative is going with the 3 in its multiplication. So anyway, I'm going to have negative 3x and positive 6 there, less than or equal to 8x minus 14. Now I want to get all the x's on one side, and I'm going to choose to move them. Well, you know what? I like to get x's on the left side. Some people don't want to deal with negative values. I think we're going to anyway. So I'm going to subtract 8x from this side. It's not the only way to do it, but that's what I'm doing. I'm also, well, let me rewrite it. I'm just one step at a time. When you get good at this stuff, you can do multiple steps at a time. For instructional purposes, I'm going to be a little careful here. I'm going to combine these two because they are like terms. So I've got negative 11x and I've got negative 3 less than or equal to negative 14. And then I'm going to add 3 to both sides. So I'm still working to get x by itself. Negative 11. How convenient, huh? Because I'm going to divide by negative 11. And did you remember to flip that symbol, greater than or equal to, because I divided by negative 1. All right, so 1, 2, 3, 0, negative 1. This says that x is greater than or equal to 1, so it's greater than or equal to positive 1. So I'm circling that in a closed circle to indicate that include that value and everything greater. All right, I believe we're on the you try section. So you try these, turn those into your teacher, and see if you got the right answer. And if you don't, see where you're making your mistakes and keep trying. Thanks.